Okay, our first task in part A is to show that dy dx equals 2 divided by 2 minus sine of y. So we'll differentiate this equation here. We will have to do it implicitly because I see x's and y's. The first thing I'm going to do is distribute the 2. So we have 2x minus 2y equals 3 plus cosine y. Okay, and now we will differentiate. Derivative of 2x is just 2. Derivative of 2y minus 2 dy dx. Derivative of 3 is 0. Derivative of cosine is negative sine of y dy dx. Now we will put the dy dx's together. So 2 equals negative sine y dy dx plus 2 dy dx. 2 equals, we take out the dy dx, times negative sine y plus 2. And now to solve for dy dx, we can divide by negative sine y plus 2. So 2 divided by negative sine y plus 2 equals dy dx. To switch the order of the denominator to match our question up here, we end up with dy dx equals 2 divided by 2 minus sine of y. For part B, we're looking for a point between negative pi over 2 and pi over 2 for y, where the tangent line has a slope of 1, and we want to find the coordinates. So conveniently, the tangent line is just the derivative, or rather the slope of the tangent line is just the derivative. So we're looking for where dy dx, which we just verified on the prior part, that it was 2 over 2 minus sine y. And we want to know when that is equal to 1. Now if we multiply both sides by 2 minus the sine of y, we get 2 equals 1, which we don't really need, right, times 2 minus the sine of y. I'm going to add sine y to both sides just to make everything positive. It looks nicer. We get sine y plus 2 equals 2. Subtract 2 from both sides. Sine of y equals 0. And between negative pi over 2 and pi over 2, sine of y equals 0 when y equals 0. So now we have part of our coordinate pair. We know the y value. And to find the x value, we'll go all the way back up to the beginning. So let's plug in 0 for y. So we'll end up with 2 times x minus 0 equals 3 plus cosine of 0. X minus 0 is just x, so we end up with 2x equals 3 plus cosine of 0 is 1. So 2x equals 4 and x equals 2. Now we have our x value. So the coordinates of point P, or where the tangent line has a slope of 1, are 2, 0. Part C, we want to determine the concavity of the curve for the points at which negative pi over 2 is less than y is less than pi over 2, and we'll have to give a reason. So hopefully, when you think concavity, you think second derivative. So we will start with our first derivative, which I'm going to rewrite, just for ease of taking the derivative, as 2 times 2 minus sine of y to the negative 1. You could use quotient rule if you want. I'd rather do this. D squared y over dx squared equals, just going to kind of leave the 2 out here, and then the derivative of this piece is negative 1 times 2 minus sine of y to the negative second power times the derivative of the inside function. Derivative of 2 is 0. Derivative of negative sine y is negative cosine y times dy dx. Okay, let's rewrite. It looks pretty ugly, but we'll end up with something okay in the end. So this is equal to negative 2 times negative cosine y, taking pieces at a time, divided by 2 minus sine of y squared, because we're putting it in the denominator, so now it's a positive, times dy dx, which we already have, and this equals 2 divided by 2 minus sine y. Getting a little bit better. D squared y over dx squared equals, well, a negative 2 times a 2 is a negative 4. So negative 2 times 2 is a negative 4, times a negative 1 is a positive 4. So in the numerator, we have 4 cosine of y. And we have 2 minus sine y squared times another 2 minus sine y. So we get 2 minus sine y cubed. Okay, so there is our second derivative. And we're looking for when y is between negative pi over 2 and pi over 2. So in terms of the unit circle, so that always helps me. This is pi over 2. This is negative pi over 2. So we're looking in here. And now when that's true, the cosine is always positive. So this will always be positive. The sine is going to be a y value going between negative 1 and 1, but obviously never actually being negative 1 or 1 since negative pi over 2 and pi over 2 are not included. Don't mind my children screaming in the background. That happens sometimes. Sure, they're fine. So since sine of y is never going to be greater than 2, this will always be a positive value as well. So, switch colors just because. Now, on negative pi over 2 is less than y is less than pi over 2, cosine of y is greater than 0. Always positive, as we talked about, because the x values here are positive. And sine of y is less than 2, because again, it never goes above 1, meaning the numerator and the denominator are both positive. So the second derivative, d squared y over dx squared, is greater than 0 on that interval, and the curve is concave up. Part D. We have our function continuous on the closed interval between 2 and 2.1 and differentiable on the open interval. And those are the requirements to use MVT. And now we want to use the mean value theorem on that interval to show this. So perhaps when you see this, you're like, I don't know where we're going to get that from. However, let's think about what the mean value theorem says. Big picture, it says that the instantaneous rate of change is equal to the average rate of change at some point on that continuous closed interval and differentiable open interval. Meaning, f prime of some c is going to equal f of 2.1 minus f of 2 over 0.1. Okay, so let's see what else we know. Oh good, conveniently we have some information up here. Oops, meant to highlight, not scribble it out. 2/3 is less than or equal to dy dx is less than or equal to 2. Let's use that. So if we know that the derivative is equal to this, we can replace this inequality up here. We can replace dy dx with what I just circled. So 2/3 is less than or equal to f of 2.1 minus f of 2 divided by 0.1 is less than or equal to 2. Okay, so this is looking, a little more like what we want it to, with f of 2.1 minus f of 2 in the middle. So now let's multiply the whole thing. I'm not going to do 0.1 because I see a fraction over here and our answer's in fractions. I'm going to multiply by 1/10 instead, which is obviously equivalent to 0.1. So 2/3 times 1/10 is 2 over 30, less than or equal to. The middle, the 0.1 just goes away, so we have f of 2.1 minus f of 2 is less than or equal to 2 times 1/10, which is 2/10. Almost there. Let's simplify. 2 over 30 simplifies to 1 over 15. It's less than or equal to f of 2.1 minus f of 2 is less than or equal to. Simplify 2/10. You get 1/5. And thank goodness, that's exactly what we wanted to show, so we are done.